Hi everyone, and we're live. Awesome. It's great to see so many people here. Welcome to Practical Go Development with AI Agents. This is a webinar that we're going to discuss some topics about that. And as we see at the end, we have a more practical workshop that is hands-on to practice more of these things. We will get the links and everything else at the end. But right now, I want to talk about development with AI agents. And if you're not familiar, my name is Miki Tebeka. I'm an instructor at Ardan Labs, uh, but I do many other things. I have several technical books outside. I organize meetups and conferences. I have videos on LinkedIn Learning, and I enjoy my time in a very geeky way. But I've been working in software development for roughly 30 years now. And needless to say, things have changed lately, right? Everybody's feeling it. Um, and, my wife is asking me what we're doing today. It's basically I'm burning some tokens and shouting at the cloud. And that's, I think everybody's sharing the same experience nowadays. And the thing is, there is a lot of advances. There are many, many advances. Everything is moving so fast, and everyone that's in the area, even people who are exploring that, Bill Kennedy here from other labs is working really on the edge, and he says that he still has a FOMO about missing all the news and everything that's coming out. Um, so, and I had the same thing, right? Like now there's Claude, now this is Codex. Now use open code, use this skill, use that. Use a lot of skills, don't use skills, MCPs, and many, many other things. And I think the approach is that it's a new tool, and we're still exploring how to use it. And I don't think anyone is really an expert. And like many other tools, like the IDEs that you used to still using to work with code, and maybe command line tools and other things, everybody has their own way of doing things. For me personally, I live in the terminal. I do stuff other people like user interfaces, and everything works, and everyone is productive in their own way. So it is totally fine to say that I'm working this way and you're working that way, but still there are some guidelines and some things that I found that really help me when we're developing with these new tools that are called coding agents. So let's start at the base, at what coding agents are built on. And these are LLMs for large language models. And in the base or the beginning of LLMs, they are what is known as generative AI. They came in to generate text. And it really at the heart, what LLM are doing are predicting what are the next words that they need to say. So you tell them something and they say, okay, we looked at a lot of sentences that people are doing that are similar to what you're asking. So we're going to answer something like that. There's not really thinking behind that. You can argue with me later on about the meaning of thinking. It's going very philosophical. But two things are built in. One is that it is always going to be random. This is how LLMs are built. There's randomness. Even if you make the temperature very cold, it's still, there is some randomness built inside. The next thing is that they are going to generate something. And that's why sometimes they just talk nonsense, but they will generate something. There are a lot of guardrails and a lot of improvement about adding logic and giving them even the ability to say I don't know, which is rare but happens. But it's rare in us humans as well, so maybe it's okay. But still, these two things are there all the time. And some people say that this is like a slot machine, right? So every time you tell the agent what to do, it's like pulling a slot machine. Some code will come out, and some not. And they're very effective because we are very repetitive, both in text when we talk and, of course, in code. And that's why they're very, very effective at generating code, because they've seen a lot of code. In code, we'd like to think that we're very unique, but we are very, very repetitive. As for the logic, so this came out, I think, 3 weeks ago. Someone asked Opus 4.6, I want to wash my car, and if the car wash is only 200 feet away. Should I start my car and drive, or should I walk? And Opus told him, just walk. It's better for you. Um, and this is an example of, you see that there's no real reasoning or logic behind it, and they're patching that. Like every time someone finds things like that, uh, the new versions that come out usually have some logic to cover that and doing other things, and there's a lot of research to add things, but from time to time you'll see these things, and it's okay with this. For this one, it's pretty obvious that this is a mistake and we shouldn't do that. But when it comes to code, sometimes these mistakes are much more subtle and really hard to catch. um, Another thing we need to think about is that these LLMs, they do not have memory. So when I ask it the question and it answers me, and then I ask another question, it will not remember the first question. What happened is there's something called the context that is always going back and forth, the whole conversation. So you start with one sentence, sending to the LLM, then it answered, then you ask another question, now three sentences or more are coming back, and more and more and more. And this context is growing. And the thing is that LLMs have an issue with big context. Even if the new ones say our context is really, really big, research showing that if you cross a threshold, their efficiency start to degrade. They start to focus more usually on the edges, and then you get results that are not that great. And you hear a lot of people talking today about context engineering. How can I supply the right context to the LLM for it to work? And this is something that we're working on. That it's something that I'm still learning. I'm working with that. There are tools to limit the context and to tell the agent, look only at this part of the code or that part of the code, because if you have a huge code base, like 100 million lines of code, not 100 million lines of code, sorry, 100,000 lines of code, which is big but not that big, it's going to eat up most of the context. And if every time you ask a question, it's going to scan the whole code base to find an answer, this is going to give you really bad results. So managing context is really important, and you always need to think of in the back of your mind, what can I do? Sometimes it's okay, when you're doing exploring and saying, this is a new code base, go over it and explain me the main things and what's happening there. It needs the whole context. But most of the time, when you actually want to do something specific which has a meaning, you want to limit the context to only things that are meaningful. Okay. On top of LLMs, we have agents. And the difference between agents and LLM is that agents can interact with the world. Right? So they have more power. They can read file, they can run commands, they can search the web, they can do a lot of other things that LLMs can do. So this gives them the power, and this is what we're working with, because when we tell them to do some tasks, they need to read the file, they need to maybe search for documentation and several other things, and they can do it on our behalf, and this is great. But on the other side, this is also very dangerous. So this is an example. I think it was a week or 2 weeks ago. An AI agent deleted the firm's entire database, and it said, I violated every principle I was given. So these LLMs, even though you tell them how to do things specifically and you forbid them for doing things specifically, sometimes they'll ignore you. And I didn't find yet a good way around that. I'm putting capital letters and asterisks and everything, but still sometimes they just do what they want without telling me. And when I asked him, he said, this is a sentence you don't like to hear from your agent, is you're absolutely right, because then you know that something is messed up. And then we need to put some guardrails and need to be aware of what is happening. Okay, so if you notice the picture at the beginning, I try to mimic the good, the bad, and the ugly in working with LLM agents. And the good thing is Go. Go is a really small language. It's really well defined, and it's easier for LLMs because it doesn't take a lot of context to understand the language Go and how it works. There's also types that also helps them understand what's going on. So as a language, LLMs find Go a pretty easy language to understand, and this is really nice for you. And the Go team is working with it. There is an MCP for Go that you can work with, and they are really aware of the revolution that we are having now with Gen AI on all these agents, and they are trying to make Go even more AI friendly as a language to work with. And also, there's another thing is that we're starting to see shift to languages that are actually solving something which is more on the infrastructure side. So Wes McKinney, if you're not familiar with Wes McKinney, he's amazing, really. He wrote a library called Pandas in the Python world. Everybody's doing data science is working with that. He wrote Arrow, which is an in-memory cross-language serialization format, and several other things. And he came from Python. Then he started working with the AI agents, and he wrote about that Python has a good ergonomics for human. It's a language which, for us human, it is really nice. But now that we have our agents writing it, these ergonomics don't matter that much. And he argues that the winner of this shift to agentic engineering are languages that solve the build system, the runtime performance, the packaging, and distribution problems. And Go shines really on all of these. So when I'm writing something in Python, and I've been using Python from 98 until today, I have a Python code that I wrote, and now I need to give it to someone else. This someone else has to have Python on the other side, where in Go we just pass in an executable. And if I'm using third-party libraries in Python, the other person has to install them. And sometimes, especially if you're doing data science in Python, these libraries can get to hundreds of megabytes in total. And by the way, it's the same for other things such as Java and Node.js or TypeScript. They have the same issues. And Python shipping executables is really nice. When you're talking about web servers, maybe you don't care that much, but still, for a lot of utilities, this is really, really great. And Wes is saying increasingly that looks like Go and Rust for that. So I know about Go. We have Herbert if you want to talk about Rust, but he's not here, I think. And the reason is saying that nobody cares about the code anymore. People are saying, you know what? I don't care how the code looks like. I just give it the specs. I see that the tests are passing. It's doing what I want. So why do I care if it's a big mess or a very elegant code? I don't really care. And I don't need to view the code, and maybe I shouldn't know about it. And some people are working like that. I'm not there yet. I think that maybe one day we'll get there. But still, I think the quality of the code is still important, and as well as the mental models and your understanding of the data structures and the data flow and the layers and a lot of other things. That the LLMs are okay with that, but they still make a lot of mistakes. And if you look at modern society, right, everyone in modern society is trusting, right? I drive a car. It was built in China. I have no idea if the people who built it actually put the brakes right or not, but I trust them. So modern society is all about trust. And some people say the same thing for an agent. Like they write code, I trust them. I don't really care about how the code looks like. I don't think it's still true. And I think that we are, in this analogy, the one who are building the cars. So we should be aware of how the code looks like and what is happening. And I work a lot with LLMs, and every time I catch them doing some nonsense. Sometimes it's interesting or nice, and sometimes it's not. So for a short example, I just asked, I think it was 3 months ago, create a Go function that concatenates two string slices, right? And this is what I got back. And it looks okay. And if you look at online, you will see a lot of examples that showing that. But it contains a very subtle bug. And if you will allow me for a minute, here's the code, right? So this is concatenate slices. And yes, I'm using Vim, I'm old. What can you do? And then I'm going to show you the problem. So we have two slices. One is it's a, and the second one is just a bug. And if I'm printing the concatenation of the slices, I'm going to see it's a bug. And then if I'm concatenating the slices of A up to 1, meaning just it's, and then B, which is a bug, I'm going to get it's a bug. But then something really interesting is happening. When I'm printing out just A, suddenly it's not it's a, but it's bug, right? And this connects to how slices are working. And if you don't believe me, right, when I'm running the code, you see I have it's bug and it's bug. So this is related to how slices work and slices internal. And that's why you need to know and understand the code that's going on. Because these things happen, and the agents are always improving, right? So if I'm going to open my terminal, and let's take Claude, for example. A Go function that concatenates, and I'm probably doing a typo, to string slices. It is going to actually scan the code. Oh, it's actually showing me that. This is alien A and B. So this is actually fixing the bug, right? To do that. And actually, let me try it again, because just before that, I tried something else. I tried it again. So I'm going to start a new session. And this is the fun with teaching or talking with LLMs, because every time you pull the lever of, it's still, okay. Last time it's actually showed me that there is a bug in the current code. It scanned the directory and looked at the current code and actually told me, look, there is already a built-in library function that does that. And this is something else that LLMs has. They've been trained on a specific time on all the code. And then if there's a new release of Go with new features and other things, they are not aware of that. And they're not aware that there is actually a library function that can do it. So they are advancing. And so this kind of bug is not there, but I'm telling you, I'm seeing them making bugs every time. Sometimes they're these bugs, sometimes they're logical bugs, sometimes they're design bugs, but they have bugs. And you need to be aware of that. You need to steer them always in the right direction. Okay, so what are the tools of the trade that we have when we want to work with LLMs?
Okay.
Yes, so that was Claude. I'll talk about it. So the first thing is planning. And I found this the most effective thing for me. So if you look here at Claude, you see that it's currently in something known as an auto mode on the bottom, a bit to the left. It's a bottom, but if I'm hitting Shift and Tab, you see it's going to switch to several modes. And the green one, this is the planning mode. And this is the one I spend most of my time with. And this is telling it, don't write any code. I just want to talk. I just want to flesh out the implementation, flesh out the design, see how things are going on. And a lot of time from here, if you get that right, everything else will move much better. And this is sometimes known as a spec-driven development. You can tell it to create a spec. There are tools like GitHub's spec kit, which you can formalize this process. But the idea is really to go and refine. And I spend most of my time in planning mode. But once I'm done with that and I'm happy with the direction it's going, usually the coding that comes after when I tell it to start implementing that is usually better. You can also tell it to write a plan. And I sometimes tell it, you know what, I'm considering doing this thing. Show me 3 approaches of how to do that and what are the pros and cons of each of one of them. And, we had it before, right? It was called rubber ducking, or just picking someone you work with and just talking with them about the idea, and bouncing ideas is very important. Don't start with the first idea that comes to your head. it's not the right one, for me at least, not usually the right one. It takes time to get it right. So now you have someone you can talk to. They don't take breaks. They will always answer you. They will always be nice to you, and you can bounce a lot of ideas with them and talk with them. There's also something called thinking mode, and you can tell uh, um, um, to think, or you can even say ultra think about the solution. So this is telling it to go deeper. So when you're planning mode, this is usually wide, saying looking at the whole picture, looking at things. And when you say ultra think, you say, okay, also go deep and think about what you're going to do. And you see the tokens are starting to run, and it's thinking. And basically now data is going back and forth from here to Anthropic. And finally, maybe we'll see a different answer. Who knows? That's the fun with AI agents. You always get something else. I have to say, for me as a teacher, I'm teaching now everything with AI agents, and it's always like a challenge because I need to be prepared for almost everything that comes out from the agent. So keeps me on my toes, which is nice. You see now it's doing a lot of thinking, a lot of more work. It's looking at a lot of more of the code, treating the actual code. It's including some rules for Go. Maybe it's a sub-agent. I have no idea. Come on, Claude. I have a lot of other things to talk about. Finish that. Okay. So we'll let it run. Maybe we'll come back later to see what's going on. So use the planning mode and use the thinking mode and bounce ideas, because once you have a good plan or a great plan, the things are going better. And we always say that we want to do a shift left to where we find the errors. If you find them on the design, it's much easier to fix them than when you find them in production or in testing. So when you give it a plan, think about the objectives. What do you want to accomplish? Don't tell it how to do it, tell it what to do it. Do it technical requirements, saying, I want to use this database because it's already in what we use in production, or other things. Think about data models, about how the data is flowing, what data we use. Think about edge cases. And also, and this is a nice trick I learned from Bill Kennedy, think about logging and metrics. Because logging and metrics are your eyes to production. And what Bill is doing is running the code, then it takes the log and feeds them to an LLM and says, can you explain me what's going on or why this run failed? And if the agent cannot explain, it means that there's something wrong with the logging. You need to add some information, because nowadays also people are using these to analyze the logs. So also talk about logging and metrics with what's coming. So planning mode is one thing. Another thing is to give the agent some guidelines and some constraints. And this is relating back to the memory. And there is a format or a file called agents.md that everyone except Claude that uses Claude.md are adhering to. And this file is basically serves several purposes. And it can be found at several levels. One is at the user level. This is one in your home directory. And this is basically your beliefs about programming. And everyone has their own. That says, for me, for example, I say prefer to use a standard library over third-party packages, and saying use the simplest code to find to solve the issue without touching a lot of other code. I don't like mocking, so I say try to avoid mocking when you're writing tests, etc., etc. So this is basically your beliefs about how you code, and you need to tweak it. The idea is that you start with something and you always tweak it. You see something bad is happening, say, okay, I need to tell it what to do. And a lot of times you can just tell the agent, add a rule to not to do that or to do that when something, and they'll write it themselves. It's going to work. So this is at the user level in your home directory. The second one is at the project level. So at the project level, on the top of the project, there's a Claude.md or an agent.md. And there you can help the agents with the memory. This is very much like the README we had for humans, but this now is for agents. And this is going to help it with the context, because you can tell him, when you're working on the front end, look at the FE directory. When you're working on the database, look at the DB directory, etc. And then when you say, I want to look at the database schema, it knows to look only at that specific context. It doesn't need to load everything else. You can tell it also how to run the tests and everything else that you do. And what I tend to do now is I just have this agents of claude.md, and I do a link, a symlink to README. So both humans and agents are looking at the same thing, and it's going there. You can also, to save context, say, you know what, for testing, look at testing.md. And then it will not load a lot of things to memory. It will know that when it's going to testing, only then it needs to read testing.md and do that. So you can save it context when it's not working on tests and working on something else. This is nice. There's also something which is at the system level, and this is if companies want an installment with some rules in place, they can also put it there. As I said, agents are following that mostly, not all of the time. For example, in my CloudMD, I tell it always work in a Git work tree. So when I'm running 2 or 3 agents at the same time, they don't step on each other's toes. Everyone has their own clean copy of the code to work with. And I would say once a week, it starts working just on the current directory. And I said, why aren't you working on a work tree? I get this dreaded, you're absolutely right. And then it moves to a work tree. But so these are guidelines, but always keep in mind that you need to make sure that they follow them and keep an eye. Second thing is that can help them with the context is that you can specify files and path, and this is usually done with the @ sign. So you're saying, I want to add a flag for verbose mode, saying this is just the only file that you need to look at. Don't look at the other files, they don't matter. And now the context is smaller, the agent will be more effective. And as you finish a task, a lot of people stay in the same agent and continue to the second task. And this is very confusing to the agent because it has a lot of context from the previous one, and then suddenly you start talking about something else. This is confusing. So there is a /new, which you can do. Oh, now we have enough context. Okay, so I'll just move that. Right, so when you do new, basically code says, okay, I'm starting fresh. This is new or clear. And now it remove the context, and now you're ready for a fresh one. And now when you're talking about adding flags, it forgets about all the tests that you tried to fix in the previous session and do that. Sometimes the memory grows, or the context grow too big. You have another option which is called compact. And basically what it goes over the context and try to prune it out so the context will be smaller, and work with it. And from time to time, if you see that you have a long session, running /compact, you'll find out that you get better answers. For that, in latest versions, actually, I got Claude saying, hey, my context is already full. I'm going to start a new session, or I'm going to compact now the memory. So we have that. There are some other things, like you can go back in history sometimes. So if you sidetracked during the conversation and now you want to go back to the main task, you can basically tell them, I want to go back to this point in history, and then they forget all the sidetrack and the context is clean for you. But playing with the context really helps with the results and what is coming out. Another thing is skills. Skills are basically a form of automation. When you find yourself telling the agent something again and again and again, or do this or do that, this is the time to write a skill. And a skill is basically just a markdown file, depending on the agent that you're using. So if you're using Claude, it's in the skills directory, and it should be called skill. And for me, I call it LGTM. LGTM stands for looks good to Miki. And this is the final of the work tree. So when I'm done, I wanted to merge the work tree back to development or main branch, delete the work tree. and commit the changes. So these are the instructions. And then once you recharge, I can do an LGTM, and then it will know what to do. And these skills can be from doing these things to how can you connect to a database and work with it. So I have some utility saying, like, if you want to access the database, this is the command line that you call, and this is how you pass it the query. And then you're going to, and then the agent, when I said, okay, remind me which table is working with that, you can do that. We also have MCPs, the same idea, basically. They expose some extra capabilities to your agent, and they can run as a service, and they can also connect to database, they can run commands, they can provide data. I'm consultant now with the company. Everything is connected to Jira, so I can ask the agent, what are my tasks, my open tasks for today? And let's say I'm working on this one. I said, mark this one is finished. And you can basically stay with the agent, and then you can do that. Okay. Another thing I want to talk about is sometimes people call LLMs jokingly as vulnerability as a service, right? I said there's a lot of power in them, but this power also comes with a lot of problems. And the nice thing about agents, they allow also people who are non-programmers to code. So people come in, they say, okay, I'm writing some code, but they're not aware of what we call the logistics of things, about security and reliability and other things. And then you find out that you have applications out there where the password is still admin, or the password is clear text in the JavaScript, and many other things. So, right, there are people on the internet which are not really nice, and you need to be aware when you're doing that, that the code that they generate, and we'll see an example in a bit, it's not always secure. It's easily also solved, or not easily solved, right, depending on the level, but you can ask the LLM to run a security audit. And that's what I do sometimes. So when I'm done with the code and tests are passing and everything is look, I tell it, now you're a security expert, do a security audit on the code. And they find stuff that they wrote, right? So why can't they be secure from the first place? But that's okay. Sometimes I pitch one agent against the other. So Claude is running the code, and Codex is doing the audit. This is also a way to get other things. Some things that sometimes we don't think about, right? So if I'm going to a new project and say, maybe set it up and running tests, everything is fine. And then I'm telling it, explain this project to me. Now it's going to read all the files. And some of these files, maybe the .env file, contains maybe API keys and maybe other things. And these API keys are going now on their way to whoever's running the agent on the web, Anthropic, OpenAI, you name it. We trust them, but it's out of our hands. So there are ways to disallow that, and there are actually ways to work with secrets which are not exposed in files in the local directory. You can encrypt the file, and then your code can decrypt it. You can use Vault, and there are several other options. But you need to be aware that everything that you're doing, everything that the agent is reading, it's not just reading it locally, it's sending it over to someone else. Unless, of course, using your own local agent, like in other labs we have Kronk, or maybe Olama, or other things that you're running on, and then you're more secure, and then you can work with that. And here I gave it a task, create a Go file called GitHub info. It should accept the username from command line, and using GitHub API, return their name and the number of public repositories. So this is the code that it generated, which is basically good code. But now when we start looking at um, in the eyes of security, this is actually nice, right? It thought about timeouts. It thought about timeouts that there are. So it knows that every time you make any network-related operation, it should be with the timeout. Usually we do it either with the client timeout, or you can do it with the context if you create new requests with context. But every time you do network operation, do add timeouts. Things happen there. The second thing, it's reading the whole response body and without limiting the size, which is again a security issue because someone can send us a very big reply and maybe blow up the memory and our application can crash. So every time it writes code, there are securities, and especially because a lot of people who are not working a lot of time in the industry, they don't have this mindset of security. And it writes, looks okay, you just go there. I highly encourage you to tell the LLM to run a security audit and see what's going on. Okay, and we talked about it earlier, right? The joke, if you're drinking coffee, it doesn't wake you up in the morning, try deleting a table in the production database. This is about the permissions that you give to the LLM. I consulted with the company, I'm doing the data pipeline for them, and he gave me a user to the database, to the production database. And I said, hey, you gave me a write permission on the database. He said, yeah, I trust you. I said, yeah, I know you trust me. I don't trust my agent. So they created a read-only user. And this thing about using the least privilege in everything that the agent touch is very much something that you need to do because, as I said, they're not predictable. You saw previously, it actually deleted code in production. So if you give them access to production, maybe just to read access, if they need to write, maybe just for a single table, maybe make sure that every time that they emit something, you see that there's no delete without a where clause in that, or maybe something like that. So think about it. You have someone who is very powerful, who is very fast, who works without getting tired, but they make mistakes with a lot of content. So and they can be catastrophic sometimes. And I urge you to read. So OWASP, they put the top 10 risk mitigation for LLMs and Gen API applications. It's an interesting read. You'll find out a lot of interesting things that happens with LLM and how people are abusing them, from data poisoning to other things. Once you read that, maybe you'll start thinking a little bit more about how much you want to trust your agent with everything that you give. Okay. Some random things that I want to talk about that came out. I couldn't find a good way of doing that. So we'll publish a link to this presentation so you can access all of these links there. So the first two are two things that I'm using and are actually helping me. One is there is a hook in Claude and other agents that you get a function call every time they're about to do something. So my hook is that every time you're about to read .env or .env I'm not allowing that. So it gets it's denied, so it's never going to read them. This is one thing. The second thing is that something that happens to me a lot is I'm telling the agent to do something, and then I'm moving to reading emails or something, and then the agent is waiting for me. And I'm not noticing that, and it's waiting and it's waiting. It's very patient, right? And then I go back and say, oh, why? I missed the 10 minutes that it could have done working. So for me, every time the agent waits on me, it prints out, it says something, and you might have heard that in the background when Claude finished. It's just notifying. It saved me a lot of time. It's silly, but it really, really works. Another thing that helps is using LSP. LSP, language server protocol. This is basically telling the agent that it can look at the code the way the compiler looks at it, for more understanding of the code. Otherwise, it looks at it as text, and basically, when it's looking for an identifier, it's just a grep. And if you have an identifier called I, good luck with that. So when it's doing that, this is nice. I found out that the JetBrains has a plugin called Go Modern Guidelines, and this is what we talked about: is that LLMs were trained on older versions of Go. It actually gives guidelines about using more modern Go. And when I started using that, started using more modern fixtures. Modern features of Go. Another thing is that you can resume a session. So instead of keeping your computer open all the time and carrying it open in your backpack while the agent is working, you can basically stop the session, close the computer, and then when you move on, you just tell it to resume. It will show you a list of sessions, and then you can pick one, and again you can resume from where you stop. I find it really, really nice. Another thing is reviews. And this is a long debate, because what happens now with agentic development is that we humans are the bottleneck. We can't review all the code. The agent is churning a lot of code. They have a tendency to over-engineer and write more code than necessary. That's my experience. And then you're just sitting there and reviewing a lot, and the agent is waiting. I think that having this system like Roborev, which I'm not affiliated with, is nice. Basically, this one installs a Git pre post-commit hook. Every time you do a commit, it starts an agent that does a code review for you, and then there's some kind of UI that you can at least see all the reviews and see what's happening and work with that. There are several other systems like that. For me, this one was nice, but it's burning tokens. Every time you do a commit, another agent starts doing a deep review. This is costing money. And eventually, and you see that the prices are going up all the time. So you need to think about that. And this is, by the way, why I'm using a lot of design mode. From my experience, it usually burns less tokens than writing a lot of code. And then going back and saying, no, it's a mistake, and do it again, because it sends the whole file back and forth. It's not fun. NVIDIA has OpenShell, which is basically a way to run your agent in a secure mode, in an isolated environment, if you want to be extra paranoid with what's going on there. I haven't tried it yet, really. I just did some nice things, but I will always keep an eye on it, because I don't like, something is running on my machine. It has access basically to the whole system, and I don't trust them. Maybe it's me, but they do funny stuff. As I said, Git workflows. I like to work with Git workflows. They're really helping me to run several agents. Also, there is a limit to how many agents I can run. My human context switch is about maybe 2 or 3 agents running at the same time. More than that, I usually losing track of who's doing what and what do I need to do. So usually I have 2. One is the one that I'm doing the design with, and that's a lot of back and forth conversation. And the other one is, hold on, I forgot to plug in my computer to the power. Okay, and the other one is, I thought you should be powered up now. If I'm interrupt in the middle of a sentence going out, it's because the battery died. I'm really sorry. I thought I hooked it up to the power, but not. And we talked about SpecIt, which actually makes this process more streamlined. I worked with it also, and it's fun. That's about it. Thank you very much. As I said, this is a taste of what we're going to do in the workshop, the practical Go development, where we're going to actually develop a project together using Gen AI, and we're going to put all of these things that we talked to into practice. We're going to write the MD file, we're going to do planning, we're going to write some skills, we're going to do reviews, etc., etc. So this is much more hands-on from the other things. That's it. Thank you very much, and I hope to see you next time.